Here we have an object moving counterclockwise in a circle. It has a constant angular velocity. I can change the radius. Does it still have a constant angular velocity? How about now? It's a little deceiving. You have to take some measurements. This definitely shows you that the tangential velocity out on the edge is much faster with a larger radius than with a small radius. Let's take a look at the y component of this motion. It looks like the mass bouncing up and down on the spring. What happens if we change the radius now? It has a much greater amplitude. Here we have a smaller amplitude. What happens if we increase the angular velocity? Oh, now we're increasing the frequency, shortening the period. Let's see if we can graph the height versus time. What does this graph look like? Here we are at the equilibrium position, just crossing the x-axis. So this is a graph of displacement from the equilibrium position versus time. Now let's see what velocity looks like. Now we've reached zero velocity. Back to the equilibrium, the greatest positive velocity. We're at the maximum displacement. Of course, it has to stop so it can turn around and go the other way. That's the velocity, zero. Let's take a look at acceleration. Where does it have the greatest acceleration? When it's all the way at the bottom, the acceleration is at a maximum. That's a negative displacement, but a positive acceleration. The net force must be this way. At the equilibrium position, there's no force, so there's no acceleration. At the maximum displacement, we have a negative acceleration. That's because the net force is down. We can see all three graphs at the same time. When the displacement is zero, it has the steepest negative slope corresponding to the negative velocity. The slope of the velocity is zero, corresponding to a zero acceleration. At the greatest negative displacement, we have zero slope. That corresponds to the zero velocity. Let's see what happens if we increase the frequency. Now we can change the radius. That's the amplitude. Can you see on this graph if the period changes due to the amplitude?